Hello, this is a video where I explore the need for air when cooling computers. I will be using a Raspberry Pi 3B because that is what I have to potentially lose to overheating. I will start with a clean install of the Raspberry Pi. I've already gone through the settings, so it will connect to my network automatically and set up the SSH server, so I will be able to connect to it via SSH. How I want to run the experiment is by a web page showing the processor usage, memory usage, uptime, and the temperature of the Raspberry Pi. But I'm not knowledgeable within Python and HTML, so I will be using ChatGPT to make it all for me while the SD card is being set up. Then to the vacuum. I just bought a cheap vacuum chamber on AliExpress, which is just a pot with a lid and a vacuum pump. Not knowing how a battery would do in a vacuum, I will be using a lab power supply, where I connected ground to the pot, then the 5V to the tubes going into the lid. The wires are just from an old mangled TP cable. Then to get the Raspberry Pi a bit up from the pot, I'm just using a plastic plate. With everything connected, I can test if the Raspberry Pi actually gets any power. And as we see, the little light blinks. Then I had to remember I didn't put in the SD card yet. Then to figure out the IP address of the Raspberry Pi. I'm using pfSense as my router, so I'll head there first to see if I can find it. Finally having the IP address, I can head over to the terminal and SSH into the Raspberry Pi. Here I'll make a folder for the script, then update the device. Back in ChatGPT, I'll copy the command to install Flask and then psutil, but I had to change the command because ChatGPT is ChatGPT. The Python script and the HTML I'm just gonna copy and paste blindly, because I don't know how it works anyway. And with that done, I can start the script and open up a web browser and point it to the Raspberry Pi IP address. And of course I forgot that I want the script to update the web page every second. Then after a bit more back and forth, I finally got ChatGPT to give me a script to do what I want. With everything up and running, I can finally put the lid on and start up the vacuum pump to pull out the air and see the temperature rise on the Raspberry Pi. With most of the air pulled out, the temperature did rise a bit, but not fast enough for my impatience. But with the processor and memory not being used, that wasn't that weird. So I found a program named StressNG that I installed on the Raspberry Pi to run a stress test on it. Then I could just run the command to max out the processor and most of the memory. But what happened now surprised me. I was expecting it to overheat fairly quickly. Of course the test isn't perfect. There's not a complete vacuum, and it's connected to the table through the pot on the plate. But I did believe that the thermal runaway would overpower that and just overheat the Raspberry Pi fairly quickly. Of course the stress test might also not be perfect. The Raspberry Pi should not thermal throttle before 83 Celsius. But I don't know how it works, and I just got it from ChatGPT, which we all know is far from perfect. After 40 minutes of it not overheating, I got a bit more confident that I would not kill my Raspberry Pi 4, so I brought that out. While setting that one up, I also shut off the stress test, which brought the temperature of the Raspberry Pi 3B down fairly quickly. After setting up the Raspberry Pi 4B and getting the IP address, I installed the same programs as I did on the previous one, copied over the HTML and Python script, and quickly got it up and running with the same settings as the one before. This Raspberry Pi is running a bit warmer from the start. The processor is a bit more powerful, and I do not have a heatsink on it. After letting it run for about 45 minutes on 100% CPU usage, the Raspberry Pi finally reached over 80 Celsius. What I get out of this is that the Raspberry Pi could probably stay on for quite a while in a vacuum, especially if you add some sort of heatsink and run it under regular loads. Shutting off the stress test sees the temperature drop back down slowly but steadily to a normal temperature. In the future, it would be fun testing this with a laptop or a miniature PC, but that is not for today. This video was probably not useful, but thanks for watching anyways. Goodbye.